Hello everyone, today in this video we will talk about our CVPR2023 paper, Vector Quantization with Self-Attention for Quality-Independent Representation Learning. Here is the information of the authors and institutions. We aimed at the problem of model robustness for potential distribution shift between training and testing data, and inspired by sparse representation in image restoration. We opt to tackle this problem through vector quantization and learn quality-independent feature representation. And qualitative and quantitative experimental results show that our method achieves better recognition performance on several benchmark datasets. Here is the overall architecture of our proposed method. Now, let's discuss it in detail. As shown in the figure, deep models are typically trained on high-quality images but have poor recognition accuracy for low-quality ones. The class activation maps also reveals that the deep features extracted from low-quality images are interfered with, affecting recognition. Recently, there exist many works for degraded image recognition, such as fine-tuning the models by mimicking real-world corruptions, recognition after restoration, and recognition-friendly image restoration. The corresponding block diagram shows the difference in their methods. From this, we can conclude that these methods are either bad in performance or complex for training. Another work that needs to be introduced is vector quantization. It's also the main contribution of our work. In compressed coding, VQ is used to compress the representation of signals. Given an input data, the algorithm needs to find the closest representation pattern in the codebook and use its index instead of the original input. It requires the codebook to represent the various input well, like an overcomplete dictionary. Therefore, the codebook should store the complete essential information of the signal. The formula below shows the selection of codebook items. The main idea of our proposed method is to learn a quality-independent feature representation. Assuming that the quality-independent feature vector has Z of an image is a linear combination of a series of features, atoms. Then we have equation 1. Naturally, we can think of using sparse representation learning as shown in equation 2, which needs to optimize alpha and E alternatively. It's complex for deep models, so we simplify alpha as a one-hot vector, and then we can use standard VQ in deep models as VQ-VAE. Equation 4 and 5 show the update method for codebooks and backbone networks. This figure shows the overall architecture of our proposed approach. The batch input of the model includes clear images and simulated low-quality degraded images for augmented training. The similarity between the feature Z extracted from the backbone network and the item in the codebook was calculated. And the most similar item is selected as the quantized feature has Z. The quantized feature are further enhanced and ultimately input into the classifier for classification. The total training loss is shown in equation 6, and it's worth noting that we use concatenate and self-attention to further enhance the quantized feature. Experiments have shown that these skills can further improve performance. And here is the ablation study. That is the impact of codebook size n and the choice of fusion model. From these tables, we can observe that n equal to 10,000 and concatenated with self-attention has the best performance. Therefore, in our experiments, we followed this setting. And here is the top 1 accuracy of each method on several benchmark datasets. The detailed top 1 accuracy result of the different methods for each corruption types in the benchmark dataset ImageNet-C. The comparison of a class activation map for deep models with our proposed method. All the above results demonstrates the superiority of our method. To sum it up, first, we proposed to introduce vector quantization into the recognition model and improve the model's robustness on common corruptions. Then, we concatenated the quantized feature vector with the original one and used the self-attention model to enhance the quality-independent feature, instead of direct replacement in the standard VQ. Finally, extensive experimental results show that our method has achieved higher accuracy on benchmark low-quality datasets than several current SOTA methods. Thank you for watching. Code is available at this website.